Hey guys, this is my presentation on tRNA and the adapter hypothesis by Summer Simone Chin. So this guy right here is Francis Crick. He's the one who came up with the adapter hypothesis. In this hypothesis, he's hypothesizing what he calls an adapter, which we now know in today's science to be tRNA, the go-between between coding and the amino acid sequence. He's hypothesizing that there is a step that acts as an adapter to go from genetic code to amino acids. So this is a central dogma of molecular biology. So central dogma of genetics, biology, it's recognized as the central dogma. So we go from DNA by way of a process called replication. And then we go from DNA to RNA through transcription. And in this particular presentation, we're looking at going from RNA to proteins through translation. That's really where we get into the adapter hypothesis and the role of the tRNA in translation. So this is our tRNA, and as you can see, it kind of does look like a clover leaf, but a great way to think about it would be to think about it kind of like a plug. You see these three prongs here, and that plug kind of acts as your adapter, the go-between between those mRNA codons and our amino acid sequence. A perfect illustration of this, well, maybe not perfect, I'm sure there are prettier, more imaginative illustrations, but this really, if you're teaching someone who doesn't know anything about genetics, this really outlines it. So you can start with the nucleic acid, and you have your codons right here. So this would be our mRNA. And then this is an adapter. You see how it's kind of pronged, just like a plug, like those three segments of that tRNA. And then we get our amino acid. And then the string through it is going to represent our polypeptide. So in a perfect world, when the tRNA follows the universal code of genetics, the universal genetic code, everything's going to be fine. You're going to have a healthy individual, but in a non-perfect world, sometimes things don't necessarily work out, and the tRNA could potentially not adapt the way it's supposed to. And if this occurs, this could look like not stopping when there's a stop codon, or stopping too early, which would lead to health issues such as organ failure or any sort of genetic disorder. My references are right here where I cite my information and my images. Thank you so much for watching, and I hope this was helpful.